So let me share my screen first. Okay, so if you can see the slides, say yes in the chat. If you cannot, say no. So can everybody see my screen? Yes, okay, good. All right, so let's start with the homework. This is our schedule for today. We are going to review. Okay, I didn't change this. I need to change this first. We're going to go over the homework, of course. Then we're going to go to quadratic functions and the inequalities with quadratics. But you get it when you get there. Okay. So let's start with this first homework problem. This is very easy. Should not have taken too long to do. So let's just do this and submit your homework answers in the chat. If you have not done this yet, then please do this. All right, so, okay, let's look at this. So who remembers how we solve for this? So to solve for this, we need to look at the symmetry of the functions. So an odd function is symmetrical with respect to the origin. An even function is symmetric with respect to the y-axis, and neither, of course, is neither, right? So when we try to determine symmetry, what we can do is we can replace the x with the negative x, the y with the negative y, that kind of stuff, to see if it really is symmetrical. So let's just do that. So for this first function, we want to determine if it's even or not. So an even function is symmetric with respect to the y-axis, right? So it's like this. For example, a parabola would be an even function because it is symmetrical to the y-axis. And to see the symmetry, we can replace x with negative x. If the equation is still the same after we replace it with x and negative x, then we can see that it is indeed going to be the even function. So let's look at that. If we replace the negative, the x with the negative x, we get negative x to the fifth minus x. And no matter what we do with it, of course, it's not going to be the same. So it's not even, obviously. And let's see if it's odd. So since an odd function like y is equal to x is going to be symmetric with respect to the origin, we can see by replacing both x and negative x with both x and y with negative x and a negative y. So when we do that, we get negative y is equal to negative x to the fifth minus x. And when you divide all sides, still keeping it equal, by -1, you can see that this is going to be equal. It's going to be y is equal to x to the fifth plus x after you divide all sides by -1. So this is odd. So that's a simple symmetry test. Now let's look at this next one. It's not going to be even, because we know something like that would be symmetrical with the to the y-axis, and it's going to be, this is a linear line, so we don't even really need to test this to see if it's even or odd. It's going to be aligned. Of course, it's not going to be symmetrical to the y-axis because it's not a horizontal one. Okay, so now if we look at this, whether it's odd or not, we can see if it's the same when we replace x and y with negative x and negative y. So let's do that. Negative y is equal to negative 2x plus 4. When you divide by -1, y is equal to 2x minus 4, which is not exactly the same. So then we can conclude that it is neither. So the first one is odd, second one is neither. And that's just how you do it with a simple symmetry test. Okay, are there any questions about this? If there are no questions, then I would like to continue to the second one. This one is really the main point that we've been trying to hit on. So let's just keep going with this. Okay. All right, so let's go over this one. Okay. Wow. You actually managed to get a graph in the chat. Okay. So it's going to be let's look at our parent graph right now. Okay. So the parent graph is basically going to be square root of x. Okay, so it's going to be looking something like this. So I received homework from quite a few of you. So how about let's find a volunteer to help us with this? Like, how would you graph this? Okay, how would you graph this? Who wants to volunteer to graph this? All right, William. Okay, so William, I would like you to graph this using transformations. Okay, not just plotting points like a lot of people do, but actually like using transformations would be better. Okay, so
since the 1/2 is inside the square root, we just stretch it, I guess. Yeah, stretch it horizontally.
okay, it's gonna
And,
like be like this.
and after that, since the 3 is outside of the square root, I think we stretch it vertically.
Yeah, now you stretch it vertically like this.
And after that, we move it right onto units.
Okay, and are you sure it's right?
I mean, no, left. Wait,
It's up.
up. I mean,
Yes, because it's outside of the square root, so it's going to be directly affecting the y. So it's gonna looking like this. So we know the general position is this, right? So how about you give me a couple of points, and then we can graph this. How about x is equal to 0, right? X is equal to 0, then y, of course, is gonna be equal to 2. So let's start plotting some points. What are some other points? Let's
so
say x is equal to 8. So then we have a good square root here and it's not a decimal. Okay, how about that? Okay.
if x is 8 and y is also 8.
Yeah, okay. So 1, 2, 3, 4, 5, 6, 7, 8. Okay. And then we get something like this. So we get the general idea. How about something like it's going to be like this, right? Yeah. Okay. We could plot more points, but I don't think there's a need to. We get the basic idea, right? We don't have any trouble with plotting points like this. All right. Okay, so let's do this now. How about we do number 3. Okay, so the absolute value of 2x minus 4. Again, do this with the transformations would be best. So make sure you do those. Then we can go over that. Okay. So are there any questions up to this point? If there are not questions, then we can continue with this problem. I'll give you a couple moments to do it, and then we can go on. All right. Yes, very good. I don't even know how you managed to get these graphs on there. Okay, that's cool. Anyways, let's look at this. So we have the absolute value graph. So let's find a different volunteer this time. Who wants to volunteer to try and graph this? So yes, okay, go ahead.
So it'll be like stretched out vertically, like by a factor of 2, I think, and then it goes down by 4.
Okay, yes. So technically, I guess that is no, I don't think so. Yeah. Okay, that's not going to be correct. First of all, this 4 is going to be inside the absolute value, which means it's not going to be a vertical shift. It's going to be a horizontal shift. And second of all, this is also inside the absolute value, which is going to be a horizontal shift too. So I don't think that's correct. So how about you help me with this new graph? All right, so let's see here. First, of course, the first thing we have to do is we have to move it to the right by 4, right? So that is this -4, okay? That's what we're doing here. And then we need
So
to,
wouldn't it be moved to the right by 2 because you multiply it by 2 at the end?
that is true. But first, we have to focus on this horizontal shift, and then we can worry about this. This will eventually change this, but I'd like to teach it in a way that is step by step. So yes, you are correct. it does shift by 2 later on. So first, this is the first transformation, right? It's something like this, right? 2 here, to number 2 to 4. But then, just like you said earlier, you have to compress it horizontally by a factor of 2, having it, right? So then, yes, we move it back to 2, like this. So the real graph should be something like this. And of course, you can plot points, do whatever, and it's going to be like, this. Yeah, it's going to be something like that. Okay, so make sure you know the horizontal shifts and the vertical shifts. They are different. So make sure you know that. And of course, once you're done, just plot some points and check it work. All right, so now let's go over the quadratic functions and the vertex form and all that. So I know most of you know what a quadratic function is. It is it's ax squared plus bx plus c is equal to 0. That is the equation form. And the function form is going to be y, or is equal to f of x is equal to ax squared plus bx plus c. That is the function form. This is where a does not equal to 0. Now, the graph of a quadratic function is what? It is a parabola. So what is a parabola? I'm sure you know it is going to be something like this. It's a U-shaped. And the domain of a quadratic function is all real numbers. Like you can plug any x in there and it'll always, this function will always be real. And that is it for the introduction of quadratic functions. So now I'm going to introduce a very specific form which you're going to use to graph it. Now I know a lot of you know how to solve the quadratic functions with what? With the quadratic formula and just factoring, but a lot of you don't know how to actually graph a quadratic function properly. And it's not just going to be plotting points, because when you have a very complicated quadratic function, you're going to get a lot of decimals and it's not going to be best to plot it, right? So first, what you're going to do is you're going to convert it to something called vertex form. So vertex form is going to be this. Let me just make a little area here. So vertex form is f of x is equal to a times x minus h squared plus k. We're going to convert this to this. And that is vertex form. Why is it so good? It is because the vertex is going to be equal to hk. And what? The axis of symmetry as well is just given to you already. Once you convert it to this form, it is x is equal to h. Now, if the a is positive, the graph opens up. If a is negative, the graph opens down. It's pretty self-explanatory. Okay. And even without finding h of k, you can find the vertex. Nonetheless, it is going to be negative b over 2a and f of negative b over 2a. So that is it, right, for the vertex. And the vertex form is useful because of its vertex, right? You find the vertex, you know exactly where the function is going to go, whether it opens up or down. Okay, so let me give an example, right? So our first example here is going to be f of x is equal to 2 times x minus 5 squared plus 3. So I'm going to give you guys a couple of minutes to try to do it according to those guidelines that I just gave you. This is already converted into vertex form, so I'd like to see how you can try to do it by ourselves, and then I'll go through it. Right, so use the vertex form guidelines that I just talked about and try to just graph it on your own. All right, so let's go over this one. So how about let's find a volunteer to help me go through this. Explain your ideas. How about Kaylee? All right. So Kaylee, help me with this. So this is already in vertex form. So how would we start this problem? Kaylee, are you willing to help?
Yeah.
All right. So what is the vertex?
It's HK, which is 5, 3.
Very good. So make sure you don't fall for this mistake. H is not -5. Since vertex form is x minus h, h is instead 5, not -5. Now, if it was x plus 5, then h is -5. And this 3 is just a 3. Okay, so the vertex is 5, 3. And Kaylee, does it open up or down?
Up, because A is positive.
All right. So we know the vertex, 5, 3. What about the axis of symmetry? The axis of symmetry is what? It's x is equal to h. So it's just x is equal to 5. All right. So now how about the x-intercepts? How do we find the x-intercepts?
I don't know.
Okay, so what is an x-intercept, Kaylee?
It's when it's a point on the x-axis, I think.
That is true. That's when the graph touches the x-axis, right? And if it's on the x-axis, what is the y-coordinate of that point?
0.
So why don't we just set y to 0, and then we'll get the x-intercept, right? So if we set y is equal to 0, then you know how to solve. What is this? This is 2x squared minus 20x plus 27. No, 8, actually. All right, I think that's it. Okay, so because this is 2 times x squared minus 10x plus 25. No, it is 50. It's 53. Okay. So, all right. So this is what happens when we set that y is equal to 0, and now we can solve for x. All right, Kaylee, help me solve this. How do we find x?
We factor it out.
We can't actually. 53 is a prime number.
Oh.
What is the other way?
Use the quadratic formula.
Okay, so negative b plus or minus square root of b squared minus 4ac over 2a. How would we do this?
20 plus minus 400 minus.
Okay, you don't need to do this part. Let me just get out a calculator. What is it? That's plus 53, right? So it's minus 2 times 53. Okay, minus 4 times that is minus 424. All right, and that's over 4. Do we have an x-intercept?
No, because negative 24 can't be square rooted.
Great. Okay. So this is technically I times that's square root of 24. That's imaginary. We don't worry about that. We don't care about that. It's not a real number. So there's no x-intercept, meaning that the graph has to be something like this. It's above the x-axis. Great. That's probably because of this +3 right here. Okay. So now let's look at the y-intercept. What is the y-intercept? That is when x is equal to 0, right? And we can see when x is equal to 0, it's just 53. Now, Kaylee, we can graph it. So we can also use some additional points, but we don't really need to worry about that too much. As long as you get the general shape right, I don't care that much. 53 is somewhere along here. That's a very tall graph. Dang. That's a very tall parabola. Anyways, yeah, that's about it for the parabola, honestly. You can graph some points to get the general details around this part. But you can do that in homework, right? Plotting points, I don't really need to go over that. You already know how to do it. So next, let's try this one. So I'm gonna give you guys another couple of minutes to try and do this one. So then I'll call on someone else to try and do this. All right, let's go over this. Who wants to volunteer for this? Are there any volunteers? You want to do this problem? Okay, if not, then how about Sophia? Sophia, are you able to do this problem?
Yeah.
All right, so first of all, you need to notice that this is not in vertex form, right? So we need to convert it to vertex form. Can you convert this to vertex form?
Well, first you would need to distribute the negative sign out.
Very good. So x squared minus 4x plus 6.
And then you would need to
Well, first of all, we need to use this technique called completing the square, because we need to make a square here. So what is the closest square that we have? It is x squared minus 4x plus 4, right? So how do we get this from this?
you would need to subtract 2.
Okay, we can do that, right? So why don't we just make that square first? So technically 6 is 4 plus 2, right? So
Yeah.
let's just make this, right? We can make this into a square, and that would be equal to what?
Wait, x squared minus 4x plus 4 minus 2.
Very good. Okay. So we make this little square here, okay? But we're not done because we still have this 2 on the outside. So we're just going to move it out. It's gonna we're gonna have -2 here, I think. Yeah, because we distribute this negative. Basically, we can count this as two identities here, and we can distribute the negative. All right, so we're basically done with the vertex form, right? Basically done. So how can we graph this now? So Sophia, what is the vertex then?
2, -2.
Okay, very good. That's the vertex. And what about the x-intercept? You have to set this to 0, right? So it's negative x squared plus 4x minus 6. And then equal to x squared minus 4x plus 6, right? So then we can solve it, right? 4 plus or minus the square root of 16 minus what is 24. So no x-intercept, is there? Yeah, there's no x-intercept. Okay, so what about y-intercepts? What is the y-intercept? Is -6 because we substitute 0 for every x in here. Okay, now we can graph, right? Now we can graph 1, 2, 1, 2 here. This is the vertex, and it's going to go down like that. They go down like this. It's going to go down. Of course, you will plot some points to figure out the direct what is it? Direct ratios, proportions of everything. But I just won't go over the plotting points. You already know how to do that. So now let's go on to the last topic for today. All right, so let's see here. How would we solve quadratic inequalities? So x squared plus 2x minus 8. How do we actually do this? So when is it less than 0? We can't just, we really don't know how to do that just by looking at it, right? So one way you can do it is you can graph it. If you graph it, then you can figure out where the function is less than 0. And we just learned how to graph it. So let's just graph it. What we can do is we can isolate x squared plus 12x minus 8. We need to create x squared plus 2x minus plus 1. That's the square that we want to create. So x squared plus 2x plus 1, but instead to get this basically -8, right? It's -9 here. So what we get is x plus 1 squared minus 9. Okay, so then what we get here is we get this vertex form, and we can get that vertex -1 and -9. So -1 here, and 1, 2, 3, 4, 5, 6, 7, 8, 9. Right, so it's all here. And we know it opens up. So if we find the x-intercept, it's going to be equal to x plus 4, x minus 2 is equal to 0. So it's 2 and -4. All right, so this is the graph. And you can see here that when is this function less than 0? It's going to be in between -4 and 2. So that is the answer to this problem, actually. But that's a bit tedious, right? That's very tedious. If every time you wanted to solve one of these, you had to graph it, yeah, we're not doing that, right? So I'm going to introduce you to a better solution. That's very good. So what we can do is we first need to factor it. X squared plus 2x minus 8 is going to be equal to x plus 4, and x minus 2 is less than 0. So what we need to do is we need to find all the intervals excluding the zeros. So what are the zeros in this? It is numbers that basically make this equation 0, right? So we're going to take -4 and 2, right? Create this sign chart. This sign chart is the key point. Make sure you create the sign chart. So we're going to take -infinity to -4, -4 to 2, and 2 to infinity. Those are the intervals, right? Excluding these zeros here. And we're going to see in those intervals what the function is. So the function is these two factors multiplied together. So when x plus 4 is greater than 0, x has to be greater than -4. So in this interval, -infinity to -4, x plus 4 is negative. But after it is greater than -4, it's positive and positive here. What about x minus 2? When x minus 2 is greater than 0, x is greater than 2. So when in this interval -infinity to -4, obviously x minus 2 will be negative. And in this interval -4 to 2, it is still negative. But when it's greater than 2 here, it's positive. And since this function is these two factors multiplied together, you can technically see the signs of the function by multiplying the signs of these two factors. So negative times a negative is a positive. A positive times a negative is a negative. A positive times a positive is a positive. And what are we looking for? Less than 0. So this interval is correct. -4 to 2. That is our interval here. Are there any questions about this? Are there any questions? Any questions? You understand, right? So that is how we do it. Okay, so let's just dive right into this one. And how about William? Can you help me solve this?
Okay.
So how would we solve this? Remember, the first step is always to factor.
So we first moved the 6x to the other side. So
Not necessarily the 6x. We can move the negative x squared to get a positive x squared. It's just better, right? But then it's just less than or equal to 0. Okay, now proceed and factor it.
so oh wait, so that just means that x times x plus 6 is greater than 0.
Less than.
I mean less than or equal to 0. And after that, we make that chart. So x
What are the zeros? Which numbers
Um,
make this 0?
so if x
0,
is
obviously.
0 or -6,
Okay, and the interval is excluding those.
so it'll be negative infinity to 0 exclude
Well, negative
exclude
6.
and -6, and then -6 to 0, and then 0 to infinity.
All right, and x plus 6. So, and how do we do this?
So
Is x positive in negative infinity to -6?
no,
So it's negative.
so
What about -6 to 0?
it can be it's mostly negative, but if it's it's negative.
It's excluding the 0, right? So it is strictly positive or strictly negative. Now, what about 0 to infinity?
Positive.
Positive, right? Now, what about x plus 6? So we need to make this equation. Sometimes you can do it mentally, right? When it's greater than or equal to 0, x has to be greater than or equal to -6. So is x plus 6 negative or positive in negative infinity to -6?
Negative.
Right. What about this next one?
Positive.
What about this next one?
Also positive.
And this is f of x. So what is the sign for this first one?
Positive,
Yep.
negative, and positive.
And what is the interval that we want?
-6 to 0.
Yes. And guess what? This is inclusive. It's negative. It's less than and it's equal to. So what we can do here is we can put the square brackets. That's how we do it. It's a very good solution, right? It's very good. Okay, now let's go on to the next one. Yeah, remember what I said about graphing? Well, I don't think you can graph this very well. So it looks like that graphing method is out of there. Okay, so now let's try to solve this one. First of all, of course, you need to make sure it's factored. So let me just give you a hint. Move the 2 to this side and then factor it. Combine the 2 and then factor everything. And then you should be able to do it. All right, guys. So let's try to do this. Okay, so how about we have someone else help this time. Who wants to help this time? How about Connie? Connie, would you like to help?
Yeah.
All right, so how would we do this, Connie?
So I think maybe you should move the -2 into like the fraction.
Okay, yes, very good, very good. So we combine it like this, right?
Yeah.
And then we can simplify.
Multiply both sides by x plus 2.
Not necessarily.
Okay.
Why can't, this is actually a very, very good lesson. Okay, so why can't we just multiply x plus 2 in an inequality? Does anybody know this? It's because, what is the key point, a key rule of inequalities? When you multiply or divide by a negative, you have to change the sign, but we don't know what x is, right? We don't know what x plus 2 is. We don't know if it's negative or positive, so we can't multiply to the other side because we don't know if the sign will change or not. So we can't actually do this. So we gotta distribute this and solve it that other way. So I'm just going to distribute it really fast. It's going to be 3x minus 3 minus 2x minus 4 is what? It is x minus 7, right? Over x plus 2 is less than or equal to 0. But this is still factored form. You still have two factors, right? We still have two factors, and since they're divided, it's basically the same as like multiplication, right? So, Connie, now we can make our sign chart.
So
What are the intervals?
you're gonna have like the intervals are gonna be negative infinity to -7 or -2. And then -2 to 7 and then 7 to infinity.
Very good, very good. And we have our intervals here, and our intervals here. This is f of x. Okay, so when is x minus 7 positive? It's going to be x is greater than 7, right? So how do we do this? This is negative, negative, and positive. Okay, now you do the next one.
So then the next one would be positive.
Okay, so let's write that equation again. X plus 2 is positive. X has to be greater than -2. So now is this positive or negative?
Negative.
Very good. What about this next one? It's positive, right? Because x is greater than -2, right? And this is also positive. So now can you tell me what are the signs for f of x?
Positive, negative, positive.
Very good. And what are we looking for? We're looking for less than or equal to 0. Great. It's going to be
Yeah.
what? -2 to 7 inclusive. Now, what if it was greater than or equal to 0? Then it'd be these two. And just so you know, it's going to be something like negative infinity to -2. Make sure you union 7 to infinity, something like this. So I'm sure that'll pop up in the homework. And that was the last example for today. So I hope you understood and took notes, and I'll see you next week. Thank you for listening, everybody. I'll probably post the homework these next few days and also the recording. Okay. And I'll see you. All right.